In 1806, the Prussian army was one of the fiercest militaries of Europe, but they had yet to face the flexibility and ingenuity of Napoleon's French army. I should say this one, not that one. Near the town of Jena, Napoleon commanded his army north, and a general advanced troops upon the order of Napoleon to take a strong position in hopes of a decisive victory. The French lined up for battle on a hill overlooking the plains beneath them. 5,000 Prussian troops met them, followed by 15,000 more. Within a few hours, Napoleon's army would face some 40,000 Prussian soldiers. This would be no easy victory, but Napoleon ordered his men to advance aggressively and encircle the enemy. The Prussians, attempting to overtake Napoleon's forces in a momentary weak position, overextended themselves. Now, the Prussians were a military rooted in deep tradition and would not deviate from the plan, no matter what. Their leaders had little to no autonomy to be industrious on the battlefield. Instead, they were expected to simply execute orders exactly as stated. The cost was steep. Within the day, the French had killed 10,000 men and taken 15,000 prisoners. Napoleon's approach was novel, especially at a time where the term officer meant nobleman. There was the gentry and everyone else, the nobles and the farmers, the chosen and the rest of us. Napoleon changed all that, but not nearly as dramatically as a little colony in the New World. Within American military circles, there is lore about the controlled chaos of American troops in the battlefield, especially during the Second World War. A Russian document stated, "One of the serious problems in planning against American doctrine, our strategy, is that the Americans do not read their manuals, nor do they feel any obligation to follow their own doctrine." A Nazi officer reflected, "The reason the American army does so well in wartime is that war is chaos, and the American army practices chaos on a daily basis." Now, the American response to this is generally, well, if we don't know what we're doing, they can't either. And I honestly can't think of anything more American. Now, our work isn't exactly war, at least it shouldn't be, but I believe tech, in its relatively infant state, as an industry, has a lot to learn from other older disciplines. American tactics aren't exactly chaos. There is a sort of order, but the actions often confound the enemy. They don't understand it because the context in which we operate is fundamentally different. The reason that old world enemies consider our methods to be chaotic isn't because it's actually chaos. It's just simply something they don't understand. America eschewed all forms of feudalism and imperialism, even as a British colony. Save for a few governors living large in London and a handful of, unfortunately short-lived, honest customs agents, colonial Americans were pretty much a band of smugglers. In the mid-1700s, a Philadelphia merchant named John Kidd estimated that out of 400 chests of tea that had come into Philadelphia, only 16 had arrived legally. Americans have always had a Wild West mentality, making their own rules, for better or for worse. And our military reflects this ethos by embracing a dilation of authority. Rather than a single person taking orders in a strict hierarchy, our army chunks autonomy. Everyone from a general to a private exists in a parameterized hierarchy. They answer to a commanding officer, but have room to be creative. And as long as they operate within a set boundary of rules, they're free to operate how they see fit, make their own decisions, get weird. I'm Emily Freeman. I'm the author of DevOps for Dummies, and I am obsessed with helping engineering organizations create company cultures in which diverse, collaborative teams can thrive. You can snag a copy of my book on Amazon. I would love to hear what you think about it. This need for distributed thinking didn't stop in the 20th century. In fact, I think it's extremely relevant to our work as developers and operations engineers. Now, if you know me, you know that I live and breathe DevOps. I love it. But I want to talk about what's next for DevOps and how we continue to evolve our thinking around engineering culture. You may think that software has nothing in common with Prussian commanders, but I beg to differ. As a quick review, software was originally developed linearly and shipped, literally, via the postal service to customers. Remember when the internet came on a CD in the mail? Good times. Developing software is a lengthy process. And in this waterfall approach, often years passed between the planning phase to the deployment phase. Now, you may think that waterfall is archaic and an abandoned methodology, but not completely. While you can update software of satellites and spacecraft, generally you're going to want to get it right mostly the first time. Failing forward gets a lot scarier when you're in a literal vacuum. Waterfall worked, but it was clunky. And like the Prussians, it left no room for adjustment, for rethinking strategy on the fly. Then came Agile. In 2001, 17 software engineers met and published the Manifesto for Agile Software Development. This was a new workflow and a response to the frustration and inflexibility of the waterfall process. Working within Agile principles, engineers aren't required to adhere to original requirements or follow this linear development workflow. Instead, they're capable of adapting to the ever-changing needs of the business, the market, and sometimes even the technology and tooling. Agile was the first methodology to really center the customer. It focused on delivering working software frequently and ensuring that that software provided value to the customer. This meant that changing requirements were welcomed and engineers were expected to communicate with business stakeholders. That never happened in Waterfall. Instead, developers would be handed a binder of requirements and expected to implement them exactly as planned. Agile was also the first time engineering teams really sat down to reflect on their performance and their efficacy, what we think of now as sort of table stakes, retros, and post-incident reviews. And although Agile revolutionized software development, it failed to address that conflict between developers and operations specialists. It was an incredible step forward, but engineering teams continued to struggle with silos around technical skill sets and specialties. Now, at the time, most teams were organized by grouping developers and operations engineers separately. Developers would write code and then toss it over to operations engineers to deploy and support. This created what is referred to as the wall of confusion. Developers had little to no understanding of infrastructure or how their applications actually reached the end user. And operations engineers had little to no understanding of application code. That lack of awareness, collaboration, is what DevOps aimed to solve. And we got close. We've done well. I define DevOps as an engineering culture of collaboration, ownership, and learning, with the purpose of accelerating the software development lifecycle from ideation to production. DevOps focuses on people, process, and tooling in that order. And the tenets of DevOps can best be summarized by a model called CALMS. Culture, how your team communicates and works with each other. Automation, how do you remove toil and reactive work by automating it. Lean, how agile or scrappy is your team at providing value to your customers. Measurement, how does your team measure its success and effectiveness? And sharing, does your team freely share responsibility, ownership, successes, and failures? In DevOps, everyone that contributes to the delivered product respects each other's contributions and is aware of the motivations and constraints of other teams. And all of these folks prioritize the customer over all else. The issue is that DevOps has become a catch-all term. Not only does DevOps mean 5,000 different things to 5,000 different people, we've added ideas to it. DevSecOps, MLOps, AIOps, GitOps, it never ends. I believe DevOps has fundamentally changed our industry. We work more as teams. We've reduced silos. We think systemically. We've sometimes embraced failure. And we're much better communicators across the full process of delivering software. But our industry has fundamentally changed over the last decade. We used to go into offices, Heck, I wouldn't have been able to have my career living in Denver 10 years ago. I would have had to move to Seattle or San Francisco, but I get to work from my basement or my yard, sometimes in my hammock, because companies have shifted to remote first cultures. In order to stay competitive and due to COVID restrictions, even the most office-centric companies have had to rethink their approach. We've moved from a monolithic architecture to a microservice architecture, where services are isolated from each other and communicate via an API. Our applications are distributed on infrastructure across the globe to be geographically closer to our customers, reducing latency, or the time between when a user makes a request and your application responds. Our technical environment, tooling, ecosystem, and culture no longer fits into the original conditions in which DevOps was created. Now, when I first pitched this idea to a friend, I was met with some pushback. People are still adopting DevOps, they said. People still aren't sure what DevOps means. Large enterprises and government agencies are still sorting out the details. And they're right, of course. I wrote DevOps for Dummies less than 2 years ago. I am not prepared to throw away DevOps and get rid of anyone who's not living on the cutting edge of tech. Now, this is the technology adoption lifecycle. It was created by researchers Beal and Bolin in 1957, and a version of it was popularized by Geoffrey Moore in his book, Crossing the Chasm. Here's the thing. Yes, companies and organizations, even people, are still adopting and implementing DevOps because it's valuable. And the ideas and practices that DevOps embodies have incredible potential to improve collaboration, reduce silos, help engineering teams deliver more resilient applications faster. But I don't want to wait until the very last person in tech decides to get on the DevOps train to start thinking about what's next. Continuous improvement doesn't just apply to our systems. It applies to us too. We know that to stay relevant and honestly employed in tech, we have to constantly learn new skills, new tools, understand new frameworks. That's part of the role. That same learning culture applies to how we think about our people systems as much as it does our software. Now, confession, I would love to be able to tell the future. That would be very handy. But I am not a fortune teller, and I really hate the term futurist. I think it's very silly. So I'm not completely certain what the next phase looks like, but I have some ideas that I think will get the conversation started. Every country across the globe has a way of war, a unique style, a grouping of tactics unique to their culture, thinking, and priorities. Individual losses are not something acceptable by Americans. Our culture puts such a strong emphasis on the individual. The outcomes of that are a mixed bag, but it's the way we are. And the military is no exception. We must win every time because the cost of life is simply too high. Therefore, we over-index on investing in training and technology to leave troops over-prepared for battle. This extreme focus on training builds trust bidirectionally across the entire hierarchy, and it is critical to American hard power. Leaders have trust in their subordinates because they've seen them in action over and over and over again in training exercises. Therefore, when a sergeant is asked to clear a building, their commanding officer knows that they'll be successful. And soldiers, likewise, when asked to accomplish a mission, know that they're not being haphazardly sent to their death. This type of unwavering trust is unique to only a handful of militaries across the globe. But it's trust that allows our soldiers to put all their brain power into the moment, into the mission. Across every branch, division, specialty, there are three main tasks that everyone focuses on: shoot, move, communicate. Shoot, move, communicate. It's built into everything, repeated ad nauseum. This means that budget goes to three areas: weaponry, transportation, and comms, with communication really being that linchpin. The other two can't happen successfully without real-time, accurate communication across all units. Now, you and I don't typically get shot at, nor do we live in retrofitted shipping containers, but I reckon we should focus on three things too: shipping, iterating, and communicating. What is the point of all of this if we're not delivering working software to our users on a regular basis, listening to them, thinking about the user experience. And once we get that feedback, the process begins again. We iterate, we adjust the roadmap, we prepare our infrastructure, we ship. But we have to do all of this in a distributed fashion, which means we have to think about this a little differently. I think we should take our cues from the bodies in which we sit right now. DNA, or deoxyribonucleic acid, I did it, contains the blueprints of how to make a human body. Well, any body, but we're human, so in this case, human. With the exception of brain cells, that rearranged DNA over time, it's unique. Almost every other cell in our body contains the same set of DNA, the same blueprint. But as we're growing, our liver cells know to become livers, and our heart cells become hearts, and our skin cells become skin. Differential or selective expression of genes is determined by genetic switches that are referred to as epigenetic markers. These markers turn genes on and off like a light switch, kind of like a feature flag. And they're influenced by hereditary factors, diet, the environment. Now, in a complex software system, I would consider those influential factors to be code, inputs or variables, and the environment, your operating system, database, infrastructure, etc. All of these systems, from the military to our bodies to our applications, they are simply too big to manage from a single point of view, to think of as one unit. Instead, we have to break it up into smaller components, supply those teams with the tools they need, practice constantly, and trust that people will make the best decisions possible in the moment. One of the unintended consequences of DevOps has been this pressure or belief that everyone has to do everything, that a JavaScript developer has to understand the intricacies of the application CI/CD pipeline or the details of cloud architecture. And on the other side of that coin, there's been this extreme focus on developers lately that's left a lot of operations engineers feeling somewhat ignored, unsure of their role. DevOps is not a methodology that encourages everyone to do everything. That is asinine. We all have specialties, and we should lean into our strengths as people and professionals while leaning on our colleagues in our team to buttress our individual weaknesses. Calms defined DevOps in so many ways by establishing tenets of focus: culture, automation, lean, measurement, sharing. Building on top of DevOps and Calms, I would like to pitch SOAR: swift, observable, accountable, and resilient. The first principle is swift. Everything needs to be moving forward at all times. There is a flow to software development. And the trick, I think, is to think of it as water. Keep the water moving and keep it moving fast. Now, this doesn't mean rush, nor does it mean to get sloppy. There's a saying in the Navy SEALs: slow is smooth, smooth is fast. Look for small improvements. And this is where your measurements and data really become critical. You have to have a baseline on which you can compare to see improvement. Otherwise, the whole thing will feel futile. Have you ever sat down after a long day of constant meetings and thought, what did I even do today? I didn't do anything. I didn't accomplish a single thing. Well, you did. It just didn't feel that way. And it's the same principle. If you don't have data to support your acceleration, you won't feel it or acknowledge it. Celebrate it even. And this is where I think SLOs and SLIs are extremely handy. A service level objective, or SLO, is a goal describing a specific measure of performance of a particular service. These objectives describe what your team must deliver to ensure the customer is having a great experience. SLOs are informed by service level indicators, or SLIs. And an SLI is a small, detailed sample of a service performance taken at a very specific time. Optimize your goals to be clear, concise, and as simple as possible. For example, an SLO would be something like, is this service's response time under 100 milliseconds, 99.95% of the time? Or is the error rate under 2%? Something like that. Now, the issue with any complex system is you can't freeze it and study it holistically. As soon as you look at it, it's different because time doesn't stop for any of us. And from 1 second to the next, your system is different. What we can do is take samples of our system and study those to determine with confidence the state of the system. Our bodies are even more complex than our socio-technical systems, and lab tests are a great example of sampling. If you have blood taken or your throat swabbed, a sample of cells is removed and studied, giving us insights to the health of the whole system. For us, SLIs are those samples, tracked constantly to give us confidence in the health of our system. Part of being swift is removing blockers and removing bottlenecks across your team. A bottleneck is congestion or blockage across a process. And these are commonly approval processes or manual tasks, toil. For example, a mandated manager approval or manual build or deployment process. Any handoff between teams can also quickly become a bottleneck because some engineers are waiting on others to continue their work. One of the trade-offs we made when we moved to a distributed cloud-based architecture and approach is that we lost some of our observability. We moved everything to the cloud, and there was this handoff of responsibility. Yes, we have to configure and optimize this infrastructure, but it's not like we have to maintain actual servers anymore or stress about environmental factors like weather impacting storage and compute. That's someone else's problem now. But with that handoff of responsibility, we immediately lost some observability into how things were running. It can feel a bit like a black box, and that's scary. Building on the measurements you'll use to implement a swift delivery of software, you want to gain as much useful telemetry as possible for your system. Now, this doesn't mean we can track every little thing. We've always had to make these decisions, choosing what information gets stored in logs versus what to let go, what behavior should trigger alerts versus what shouldn't. This isn't new, but these aren't decisions that humans should really have to make on a daily basis anymore, which is why I think AI ML is really interesting in this area. How can we train our systems to self-diagnose, alert us to issues or areas of concern before there's ever a user impacting incident? AppDynamics conducted a survey of AI ops in 2018 and found that 91% of enterprise companies reported siloed performance monitoring. This means that service teams only track impacts to their particular areas of responsibility. Now, I hope this has changed over the last 3 years, but experience tells me it probably hasn't. Now, we know that in a distributed system, nothing is ever fully decoupled. The intricate behavior of the system requires holistic monitoring, something machines are pretty good at if trained. Now, imagine being alerted that your load balancer isn't behaving correctly before a single server falls over, long before a user ever knows something's wrong. Imagine knowing with confidence which services in your application to focus on and to optimize first because they contain the most transactions or impact the most revenue or cost the most in compute. That's the future in which we're headed. Finally, everyone in your organization needs access and training to these resources. They should not be reserved for only a few engineers. Prioritize autonomy, chunk responsibility, and enable your team to solve problems independently. I prefer the word accountable over responsible. Accountability is a willingness to account for someone's actions, whereas responsibility is having control over a situation or a duty to deal with it. Now, as a mom, I'm responsible for keeping my child alive. I provide basic necessities, food, shelter, clothing. But the higher order role I have is to love her, to model the principles I value, and to train her to be a self-sufficient, functioning human. And that's where I'm accountable to her. I make decisions daily, and I never know if I'm choosing correctly. But I do know the information I use to make that decision and how I came to the conclusion I did. When she's older, I'll be able to account for my decisions. And even in the cases where I'll have chosen incorrectly, I'll have confidence that I made the best choice given the data I had at the time. That's really all of us, all we can do. And it's that concept that I think is a critical differentiator in reflecting on performance and incident response. We can say blameless until we're blue in the face, but it's an instinct of humans to throw someone else under the bus when we're stressed. That lizard brain in the back of your skull, it has one job, and it's to keep you alive at all costs. When you feel fear, that gets triggered, and there is no way to unwind that adrenaline response. I think if we shift the conversation from responsibility of an incident to accountability, it reframes the entire conversation. This accountability extends to your role as well, in that you are accountable for having an awareness and respect for the work of your peers. You shouldn't have to ever write a line of JavaScript to appreciate the language's capabilities, opinions, and the choices that developers have to make. It's this awareness and respect that enables everyone to come to the table as equals and contribute to their delivery of applications. The final tenet is resiliency. I like to think of this as grit. I've always said that my greatest advantage is that I can take more hits and get back up than the average person. I've seen some things, and I've learned that the only path forward sometimes when you get knocked down is just to get back up. Now, you don't have to pop up like an overcaffeinated gopher. You can take your time, but you have to stay in the game. You can't lose as long as you're in the game. So just keep moving forward, even if it's at a snail's pace. Now, we've talked about resiliency from a technical perspective for years, mitigating disaster, practicing failure through chaos engineering or fault injection, ensuring services recover quickly. But for me, I think resiliency of a team is a fascinating topic. I mean, what causes one team to recover from stress while the other collapses? Perhaps what's most fascinating is that the stimulus, the stress, it doesn't have to be big to be observable. Imagine two teams. They receive free lunch at work, and their boss lets them know that free lunch is over. No more Taco Tuesday for you. Now, one team's going to collapse into a frenzy of complaints, extrapolating the end of lunch to things like, will there be layoffs? Do you not value me? Are you going to increase my salary to adjust for this loss of compensation? Now, the team ruminates on this, has no ability to mourn and then move on. But the other team, they have a momentary adjustment, but realize that they can use that time to instead explore their city with their colleagues. They organize lunches a couple times a week. Same stimulus, different reactions. And I believe it comes down to psychological safety and group power dynamics. In order to build a resilient team, you have to grant autonomy and trust and train them to not only work better as individuals, but as a team. Practice may not make perfect, but it sure does make better. And I think when managers hear psychological safety, they often think they have to treat their teams with kid gloves. That's not true. Hard conversations around performance and expectations, they're always going to be part of that dynamic. But you have to communicate expectations early if you're going to hold someone accountable. And you have to communicate your appreciation of their work just as clearly, perhaps more so. People need to know that they're valued, that they have room to grow, that someone has their back, that they're safe. It's these characteristics that build a resilient team and should be fundamental to your daily practice. In a distributed socio-technical system, you have to think of DevOps like DNA. And each component in the system, especially those human components, are like cells with those epigenetic markers. They can carry all the information they need to implement DevOps: trust, training, authority, autonomy, tools, all of it. But they can pick and choose what aspects of it suit their unique circumstances. Now, there's some nuance here. I'm not saying you get to toss key tenets of DevOps because they're hard. This is hard. What I am saying is that you can lean into the aspects of it that fit your immediate needs while maintaining an awareness and respect of the people around you and their work. I believe as we move to this distributed approach, we will build teams capable of delivering better software faster and more reliably. I think the next 10 years are going to be fascinating. Now, I can't tell you exactly how it's going to turn out, but I have an idea of where we should go from here. And I'm going to focus on doing the next best thing. Our approaches and architecture and priorities continue to shift like sand. But through all this change, I believe we're building something truly amazing. And I'm glad to be with you as we build it. Thank you.